All right, let's do a couple more theorems. This is a nice one. So if you have coprime integers, remember, coprime means that the greatest common divisor of the two numbers is 1. They share no common factors, no common divisors. So if you have two coprime integers, well, you can write any other integer as a linear combination of these. And this is kind of easy to see. So by theorem 38.1, remember that said that since we know the greatest common divisor of A and B is 1 because A and B are coprime, then there's a linear combo such that the linear combo, let me write as ax plus by because that's how I did it before. Ax plus by indeed equals 1. So we know that from theorem 38.1. And now let's pick any integer we like. Let's call it c in the integers. So let's multiply actually, let's change this theorem a little bit. I should say, well, no, I don't even need to. That's fine. Let's multiply both sides by c. So let's do it. So then we get, well, a times cx plus b times cy is indeed c. And we're done. So we just showed that as long as there's a linear combination of a and b that equals 1, you just multiply both sides by any integer that you like, and you get a linear combination that equals whatever number you want. It's just that multiple of x and y. So that's pretty cool and pretty easy. So let's kind of do something along the lines in the other direction. So let's do the following theorem. 39.4. If there are integers x and y such that ax plus by is indeed 1, then the GCD of a and b is 1. Well, let's do it this way. Let's call D the GCD of A and B. So we know that D is a factor of A and D is a factor of B. Since it is the greatest common divisor, it's a common divisor of A and B. Well, what does that mean? Thus, well, we know D is a factor of AX plus BY. It's a factor of any multiple of A, and it's a factor of any multiple of B, and it's a factor of the sum. Let's just say here, by previous results. I forget exactly where they were, but they were either on your assignment or in a previous lecture. So we know that. But since we know that ax plus by indeed equals 1, we know that D must be a factor of 1 as well because they're equal. So what does that mean? So D must be 1. And in fact, let's do it like this. I'm going to change this on the fly because this is probably an easier way to see it. Let's not make D be the greatest common divisor. Let's just make it be any common divisor. So let's say here, a common divisor of A and B. So if we make it any common divisor, everything here still makes sense, but we find that that common divisor has to be 1. So if the common divisor has to be 1, then we know that D has to be the greatest common divisor because we found that the common divisor had to be 1. So it's the only number that makes sense. It is the greatest common divisor. All right. So we're finished with that result. Let's keep going. And let's do the next theorem. So this is theorem 39.5. And this states the following. If n is a factor of a times b, and the greatest common divisor of n and a is 1, so n and a are coprime, then n must be a factor of b. And basically, this is a corollary. A corollary is just a word that means a proof that follows directly from another proof. So it's a corollary of 39.3. So since the GCD of n and a is 1, well, by theorem 39.3, we have there's an x and a y that are integers such that, oh, wrong color here, back up, such that ax plus, let's say, ny, because it's the GCD of n and a, equals 1. We're going to multiply both sides by b like before. And we get the following. We get that so let's write this out. I'm going to write it like this. AB x plus n by equals b. But let's look at these two terms here. So we know the following. We know that, well, here's AB. By hypothesis, n is a factor of AB. And, of course, n is a factor of n. So n is a factor of both terms, so n is a factor of the entire left-hand side. So let's write that down. Thus, since n is a factor of AB and n is a factor of n is a factor of the entire, I'll just write it as left-hand side. But since the left-hand side equals the right-hand side, but the right-hand side is b, Well, n is a factor of b, and that's what we wanted to show.